So, welcome to lecture 6, classes and objects. So, we briefly define how we can create the classes in C++, right. So, we have also studied it is nothing but the blueprints for creating objects, alright. So, once you create a class, right, assume that you are creating a class. So, it encapsulates the data, alright. So, in fact data, that means the attributes and the behavior which is called functions or methods, alright. So, in a set notation, alright, so we can define this as a tuple, alright. So, here it is nothing but a tuple. C is equal to a comma m, where a we call it as a set of attributes. Suppose you are using the data, right, you call it as a member data, and m is nothing but a member function, or you call it as methods. So, we have already talked about how the syntax works in C++. So, when I define a class, right, so here you go, you will write the keyword called class, right. So, we will have a class keyword, and then the name of the class, you are opening the braces, the code block is starting over here, and you have the member data called attributes, and you will have the functions. You can have several attributes, you can use arrays also, alright, and you can have several methods, several functions, right. You call it as a member data or member variable or member function, and then you will have the end parenthesis with a semicolon. In the case of C++, you should have the semicolon. This is how we can define a class in C++. So, what is the motivation behind, alright, for class design in C++? So, when we are writing object oriented programming, so as we had seen, it is mainly based on the objects and classes, right, which is a very powerful paradigm, alright. So, this can solve the wide variety of problems. So, you can have the list of problems over here. So, the list of problems, when you are having a class, you can have an object, right. So, class, and from the class you can create the object, and we can use some of the object oriented programming concepts like inheritance, polymorphism, encapsulation, etc., right. So, all these can be effectively applied, right, we can apply. So, now we had seen, right, in the few classes back we had seen the tangible objects and intangible objects. So, for example, right, so intangible objects, assume that I want to create a class, or I have to solve the problem using object oriented programming for library management systems. So, when you have library management systems, you can think of, right, books, users, right, loans, staff members, right. So, these you are you are modeling these as classes, right, you are modeling these as classes. Like then we have attributes, for example book title, right, due dates, and behavior like borrowing or returning the books, right. So, the attributes, I define book title, you call it as a member data. Then we can have what are all the due dates, and then if I want to write certain functions like borrowing or returning the books, right. So, this is how I can think of the blueprint for the library management system. Similarly, banking system, right. So, classes can represent customers, accounts, transactions, right. Your method can include the deposit, withdrawal and balance inquiry. So, when the intangible objects like banking systems, so how I can have a class. So, from the class, right, I mean I can represent the customers, account and transactions, and then I will have set of member functions, alright. So, like deposit, withdrawal, balance inquiry, etc., right. So, this is how I mean I can think of writing a object oriented code for these kind of problems. Similarly, suppose you are interested in, let us say, gaming, the chess game, alright. So, I can think of classes for pieces like pawn, king, rook, queen, alright. So, because they have a specific movements and behaviors, alright, and also I can think of the board, right, the board can be an object. So, that can have all the pieces. So, when you are writing any games, right, the chess is one of the games. So, if you want to have, right, other board games or any other games, you can think of in object oriented way. Similarly, traffic simulations, right. So, we can think of vehicles, roads, traffic lights. So, these can be objects, right. So, when I am talking about the classes of this problem, right. So, the classes can define the behavior of every component, right, of this traffic simulation, right, and the methods simulate movement and traffic flow, right. So, when I am thinking about traffic simulation, so I can write a program using object oriented programming. Similarly, when you are going for the data structures like a linked list, stacks, queues and trees, alright. So, once you are done with, let us say, C++ and Java, you can think of next one is a data structure and advanced data structure. So, I can define a class node, right, class linked list, class stack, class queues, class binary search trees, class AVL trees, right. So, these are all nothing but the classes, and you can have, right, several methods: insertion, right, or addition of the node, removal of the node, or I want to manipulate certain data. So, these are all coming under the methods, right. So, you can think of whenever I have a linked list or any data structure. So, the data structure can be a class, and then the several operations, you can have several operations. Those operations are nothing but the methods or member functions, right. Similarly, we are in the artificial intelligence paradigm, right. In neural networks we can use object oriented programming like layers, neurons, the connections, right. So, these are all can be considered as the classes. And then when I am talking about the methods, you have a forward propagation, backward propagation, and you have to train the model, correct. So, when I want to have object oriented concept in neural networks, so you can think of, so the main idea of all these problems that I have suggested, right. So, you have a class, so from the class you can have the objects, right. So, once you have the objects, let us assume inside the class you can have set of member data, you can use any data, it may be integer or double or float or even array of integers, right. You can think of these are all the member data and several member functions, right. When I am talking about the data structure, I have to write a method for insertion, deletion, update, pop operation in stacks, peep operation in stack, push operation in stack. So, all these operations, when I am talking about the operations, they are nothing but the methods, okay. So, this is how I can think of using the object oriented programming, how I can solve these kind of problems. So, similar to class design in C++, so we have class design in Java, alright. So, when we talk about the class design in Java, so here you go, alright. So, you have name of the class, so here you have name of the class, right, the class name, and then you have attributes and methods, right. Attributes is nothing but data member. So, in Java you call it as data member, and then you can have set of methods. So, methods are nothing but the behaviors or operations or the functions that you are calling in C++, you call this in Java. So, the class is the keyword and you can have a name of the class, you can have an attribute, you can have a method. So, only thing after brace is you should not have a semicolon, okay. So, this is how we can define the class in Java. So, now you know how to create a class, how to define an object, right, or how to declare an object, or I can say that how to instantiate an objects, right, instantiate an object or instantiate the objects, right. So, this you know that. So, with this we will see some of the problems, okay. So, now write a C++ program to multiply two complex numbers using class and objects, alright. So, you have to multiply two complex numbers. So, how do you define a complex number? So, C is equal to, let us say C1, A1 plus IB1. So, this is one complex number, and C2 is equal to A2 plus IB2, right. When I multiply C1 into C2, it is nothing but A1 plus IB1 multiplied by A2 plus IB2, correct. So, which is nothing but A1 into A2, I squared is minus 1, therefore, I will get minus B1 into B2, correct, plus I into B1 A2 plus A1 B2, or I can write B2 A1, right. So, the multiplication when I am doing the product, right. So, I have to get this as the output, right. So, these two numbers will be the input. So, it is a pair, the pair will be the input and the program has to multiply these two complex numbers and I have to get the output like this. So, now the user will give you the numbers A1 B1 the pair, A2 B2 the pair, and the resultant I have to get this, right. So, how we are going to solve this using object oriented programming. So, let us consider this program, alright. So, let us have the class complex, right. I am creating a class complex. The idea is we have to multiply these two complex numbers, right. I am creating a complex, class complex. So, when I write C equal to A plus IB, right, this A is a real value and B here is I into B, we can call it as a complex imaginary value, alright, it is a imaginary value. So, therefore, we have float real and float imaginary is a member data. So, you have two member data, the member data are float real and float imaginary. Next, you have set of member functions, alright. You have member function called set values, usually we see this getter and setter function. So, set values. So, you have two parameters float r and float I, right. So, whatever you are setting the value or taking the value from the user real and imaginary, right. So, here r will be assigned to real and I will be assigned to imaginary, right. Sooner or later we will talk about the access modifiers, the private and public, alright. So, right now still it is a keyword I have not explained. So, we will once we talk about we will again see the complete program. So, right now no need to worry about the private and public. So, that is the reason here R will be assigned to real and I will be assigned to imaginary, right. So, I can access this inside the class, that is the meaning. So, when I am taking the input from the user, right, R and I, so based on this function, so when I am passing these values in the main, so now R and I you will have the value, so that will be assigned to real and imaginary. So, this is one function and then you have another function called multiply, right. So, here we use the keyword static. I will explain about static, maybe we will see one or two examples, right, how we are defining the keyword static, alright. So, now complex multiply, right. So, here you have the multiply function whose return type is the, right, the return type is the object, right, your return type is the class complex, right, your return type is class complex. So, I will take complex address C1 and another one is complex address C2, right. So, suppose I have, if you would have done the reference operator int address C1, right, assume that I have int let us say C2 equal to 10, right. So, when I write int C2 equal to 10, so we know that let us say this will be stored in some address, assume that the address is having, let us assume this is your memory location, right. So, this is C2 taking the value 10, alright. So, now if I put int address C1 which is equal to C2, right. So, now if you look what is address of C2, address of C2 is 4002, address of C2 is 4002, correct. So, now when I write like this int address C1 equal to C2, the meaning is address C1 is also pointing to the location 4002, right. So, that is the meaning of this, because we are using this syntax over here, alright. So, maybe the syntax go like this complex when we are calling the function. So, you will give like this some let us say C11, alright. So, the meaning is address C1 and address C11 both are same, right. When you are doing like this address C1 and address C11 both are same, address of C1 and address of C11 both are same, alright. So, with this in mind we will again come back when we are calling this particular function in line number 17, alright. So, this concept will be useful to you. So, now as we worked out, right, how to multiply two complex numbers, right. Maybe one more time I will do it A1 plus IB1, because here we have set of expressions, right, into A2 plus IB2. So, we know that it is A1 A2 minus B1 B2, I squared is minus 1, right. This will be your real plus I into A1 B2 plus A2 B1, right. So, now if you look this is a resultant, right, the resultant complex number let us say C3. So, C3 will be, it will be like A plus IB form, right. C3 will be some x plus IOI form, right. What is x? That is real. So, x will be let us say C3 is equal to x plus IY, alright. In that case x is equal to A1 A2 minus B1 B2 and y is equal to A1 B2 plus A2 B1, right. So, this you call it as result dot real, x is nothing but your result dot real. So, you can see that C1 dot real into C2 dot real, which is nothing but A1 into A2, right, and then you have minus B1 into B2, C1 dot imaginary into C2 dot imaginary, B1 B2, and imaginary C1 dot real A1 into C2 dot imaginary B2, right. Similarly, C1 dot imaginary into C2 dot real, right. So, that you have evaluated this and then return result, right. So, result is a complex number, you can see the return type is complex, right. So, this is one main function. So, you are another member function over here, and the last member function is you are displaying, right, you are displaying real and imaginary, right. So, if imaginary is greater or equal to 0, you display a plus ib, otherwise a minus ib. So, that is the reason, that is why it is been taken like this, right. So, basically you are displaying a plus ib or x plus iy form. Okay. So, up to here we have written the class, correct. So, this is how we define the class called complex. So, you have real and imaginary data members or member data, and then you have member functions called set values, multiply and then display. So, now come to the main program. So, the main program we are creating two objects C1 and C2, and then you need another object called result, right. So, you obviously require result is equal to C1 star C2, where C1 C2 are the complex number. So, result the third object, right. So, now you will have C1 is nothing but A1 plus IB1. So, you need real 1 and imaginary 1, and C2 is A2 plus IB2. So, real 2 and imaginary 2. So, take the input from the user. For example, I write 2 plus 3i, and then another one is 4 plus 5i, right. In that case, I have to write C in real 1, C in imaginary 1, alright, and then you will have C1 dot set value. So, now you are calling the object C1, you have already defined over here. So, the object C1 is invoking the member function, called set values using the dot operator. So, you have the object is invoking using dot operator and one of the member function called set values, right. You are passing real 1 and imaginary 1, right, you are passing real 1 and imaginary 1. So, let us say what is happening in the set values, right. So, here you have set values, assume that I am passing 2 and 3, alright. So, your real is 2 and imaginary will be 3, right. For the object C1, your real is 2 and imaginary is 3. So, this is the meaning. And then similarly, C2 is invoking, right, you are taking 2 more input, real 2 and imaginary 2, right. So, this is your real 2, this is your imaginary 2, right. So, now C2 is invoking set values member function, right. You have a dot operator and then you are passing real 2 and imaginary 2, assume that I am passing 4 and 5, correct. So, when I am passing 4 and 5, so what I will get, my R real will be 4, imaginary will be 5, right. C2 dot real will be 4, C2 dot imaginary will be 5. So, this is the meaning, alright. So, finally, alright. So, here under the class complex, alright, you have scope resolution operator, right, and then you are having multiply C1 comma C2. So, this means I can write this function outside the class, alright. So, when I am writing this correct in the main, alright, so I can do that. So, that means I am calling this particular function multiply, alright, I am calling this function multiply, correct, with passing 2 arguments C1 and C2, alright. So, when I am calling multiply, let us see what is happening. So, here you go multiply. So, complex address C1 which is equal to C1 that you are passing from here, right, C1 dot real, C1 dot imaginary. Similarly, complex C2 which is equal to C2, right. So, that means address C1 and address C2. So, here your C1 over here, right, you have an object C1 in the main, alright. So, you have object C1 in the main, object C2 is also in the main, correct. So, which is you are creating an object with some address value, right. So, for example, I create C1 whose address is let us say 4002, address of C1, and I create C2 whose address is 4006. So, once I have this, when I am calling this, your address C1 equal to C1. So, that means C1 when I define inside the function, C2 I define inside the function, both will have the same address what you have defined outside the class, that is the meaning. Okay. So, now rest is fine, C1 C2 you pass, that means C1 real, C2 imaginary, C1 imaginary, right, and C2 real, all you have passed, and then this computation will be done. So, once this computation will be done, we know that, right. So, the complex multiplication is happening and then you are displaying the result. So, you are getting a result, alright. Your result is the object whose class is complex, alright. So, therefore, you have a complex class. This is called scope resolution operator. And then you are calling the multiply function by passing two arguments C1 and C2, right. So, multiplication will be done when you are calling this function and the result is invoking. So, result of multiplication, this is invoking display, right. So, that means result dot real and result dot imaginary will be displayed, right. So, this is what exactly happening, alright. So, result dot real and result dot imaginary will be displayed. For example, assume that we are giving 2 3 right, 2 plus 3i the same, right, 2 plus 3i as a one input and another input is 4 plus 5i, correct. So, when I multiply these two, what I will get? So, I should get minus 7 plus 22i, this is obvious, right. 2 into 4 is 8, 3 into 5 is 15, I squared minus 15 plus I into 3 into 4 is 12 and 5 into 2 is 10. So, 8 minus 15 is minus 7 plus 12 plus 10 is 22i. So, I should get this as output. In fact, so this is giving the correct output, right. So, this is how we are doing the complex multiplication using class and objects, right. So, what exactly we have done? So, we have created a class, right. So, the class is a complex, the name of the class is complex, and then you have member data. So, real and imaginary or member data, and then you have set of member functions called set values, right, and then you have multiply, this is a main function, right, main member function called multiplication, and then displaying, right. So, you can display maybe the number 1 C1 complex 1, A1 plus IB1, complex 2 A2 plus IB2. So, this you can display, right, and then result. So, once you are doing the complex multiplication, right. So, once you are doing a complex multiplication, so the resultant can also be displayed using this. So, that means whenever you are creating an object, you have member data and member function. So, here we have used 2 member data and then 3 member functions. So, up to here line number 31 you have class. So, once you have a class, when you go to the main program, you are creating objects, alright. So, C1, C2 result, these are all the objects. So, you know how to create a class and now you are instantiating an object or instantiating objects. So, the objects are nothing but C1, C2 and result, right. So, you have the complex class and then the usual float, real 1, imaginary 1, real 2, imaginary 2, right. So, usual data type. So, that you have used in your procedural oriented programming, right. So, then you are taking the input from the user. So, when you are taking an input from the user, these set values will set, right, where C1 is invoking set value, C2 is invoking set value, and it is nothing but you have A1 plus IB1 and A2 plus IB2, and then you are calling the multiplication function. So, here I am using the reference operator. So, the reference operator C1 when you define the object in the main, C1 you are defining object inside the class. So, both are pointing out the same location, alright. So, this is how we have seen the concept of that integer, right, integer address A or integer address C1 equal to some C11. So, both C1 and C11 pointing to the same address, correct, and then when it is multiply is invoking, right. In fact, the multiply when you are calling this function with the C1 and C2 passing the arguments. So, these two will be multiply. C1 and C2 will be multiplied and the resultant will be over here, right. You are calling the multiplication member function. So, it will throw the result. So, result is of the form x plus iy complex number. So, that we are displaying. So, we have given the sample test 2 plus 3i and 4 plus 5i. So, and then we got the exact output, alright. So, this is how we can have a class and then create an object and you can solve, as I said, several problems. This is one of the mathematical problems, right. Similarly, you can think of, right, the banking system. In fact, you can think of neural networks, or we will go, right, how to solve the problems like data structures, right. Create a class, let us say linked list, or even the arrays, alright. So, create a class arrays and then you can do set of operations like insertion in arrays, deletion in arrays, updating the arrays, or you can write the program like searching, you can write a function like searching, member function like searching, sorting, alright. So, the main idea is, so with the help of object oriented programming, right. So, you all might have studied procedural oriented programming, you can think of, right. So, creating a class, right, defining a class and creating an object and then, alright. So, you can invoke many functions, alright. So, here we had seen several keywords, right. So, one of the keywords you are seeing over here, we will talk about private and public slightly later, and here static, alright. So, in the next class we will see few examples about static, alright, and then, right, how the static works without static variable or with static variable, how the results are being changed. So, that we will see in the next class. Thank you.